Alrighty, today we're going to be looking at finding arc lengths of circles. So just as a reminder, if I wanted to find the circumference of the whole circle, well, I would just use 2 pi r. But since I only want a portion of it, I can instead do the angle theta over 360 if it's in degrees times 2 pi r. And that's going to be the arc length, which we might call L. So visually, this is the arc length right here, because it's a portion of the circle. So it's going to be 40 over 360 times 2 times pi times the radius, which is 16, which is equal to, alrighty, and using the calculator, that is 11.17 centimeters. And it's centimeters because it's a distance, it's still a length. The second question asks us to do the same thing, but in radians. Well, we have to think about, well, what did we do over here for degrees? Well, for degrees, we divided by 360. Why? Because there are 360 degrees in a circle. For radians, there aren't 360 degrees, there are 2 pi. So the length is going to be 2 pi r times how much? The angle, theta radians, over 2 pi. Now we're going to get a fraction and a fraction because the angle in particular we've got is pi on 5 over 2 pi. And our radius, which I didn't substitute in, times pi times 10. Now just before we type this in the calculator, just make sure we can clean this up a little bit. When we've got a fraction like this, it's pi on 5 divided by 2 pi, which is the same as pi on 5 times 1 on 2 pi, which is pi on 10 pi, which is 1 on 10. So big takeaway that I'd be going is that the 2 pi kind of joins the 5 on the bottom, and we get pi on 10 pi. And now we can just use our calculator to get the exact value. It's equal to 6.28. And once again, centimeters, because that's the units in the question. Alrighty, so these are kind of our different rules that we could use to work out lengths of arcs. Alrighty, I'll see you in the next one. Goodbye.